one of the incredible things about this moment that we're in right now is that we no longer have a lot of the technological limits that we had in a world of CPUs and sequential processing. And we've unlocked not only a new way to do computing but also a way to continue to improve. Parallel processing has a different kind of physics to it than the improvements that we were able to make on CPUs. I'm curious, what are the scientific or technological limitations that we face now in the current world that you're thinking a lot about?
Well, everything in the end is about how much work you can get done within the limitations of the energy that you have. And so that's a physical limit. And the laws of physics about transporting information and transporting bits, flipping bits and transporting bits, at the end of the day, the energy it takes to do that limits what we can get done. And the amount of energy that we have limits what we can get done. We're far from having any fundamental limits that keep us from advancing. In the meantime, we seek to build better, more energy efficient computers. This little computer, the big version of it was $250,000, baby digits. Yeah, this is an AI supercomputer. The version that I delivered, this is just a prototype, so it's a mock-up. And so the very first version was DGX-1. I delivered to OpenAI in 2016, and that was $250,000, 10,000 times more power, more energy necessary than this version. And this version has 6 times more performance. I know, it's incredible.
We're in a whole new world.
And it's only since 2016. And so 8 years later, we've increased the energy efficiency of computing by 10,000 times. And imagine if we became 10,000 times more energy efficient, or if a car was 10,000 times more energy efficient, or electric light bulb was 10,000 times more energy efficient. Our light bulb would be right now, instead of 100 watts, 10,000 times less, producing the same illumination. Yeah, and so the energy efficiency of computing, particularly for AI computing that we've been working on, has advanced incredibly, and that's essential because we want to create more intelligent systems, and we want to use more computation to be smarter, and so energy efficiency to do the work is our number one priority.
When I was preparing for this interview, I spoke to a lot of my engineering friends, and this is a question that they really wanted me to ask. So you're really speaking to your people here. You've shown a value of increasing accessibility and abstraction with CUDA and allowing more people to use more computing power in all kinds of other ways. As applications of technology get more specific, I'm thinking of transformers in AI, for example. For the audience, a transformer is a very popular, more recent structure of AI that's now used in a huge number of the tools that you've seen. The reason that they're popular is because transformers are structured in a way that helps them pay attention to key bits of information and give much better results. You could build chips that are perfectly suited for just one kind of AI model. But if you do that, then you're making them less able to do other things. So as these specific structures or architectures of AI get more popular, my understanding is there's a debate between how much you place these bets on burning them into the chip or designing hardware that is very specific to a certain task versus staying more general. And so my question is, how do you make those bets? How do you think about whether the solution is a car that could go anywhere or it's really optimizing a train to go from A to B? You're making bets with huge stakes, and I'm curious how you think about that.
Yeah, and that now comes back to exactly your question. What are your core beliefs? And the question, the core belief, either one, that transformer is the last AI algorithm, AI architecture that any researcher will ever discover again, or that transformers is a stepping stone towards evolutions of transformers that are barely recognizable as a transformer years from now. And we believe the latter. And the reason for that is because you just have to go back in history and ask yourself, in the world of computer algorithms, in the world of software, in the world of engineering and innovation, has one idea stayed along that long? And the answer is no. And so that's kind of the beauty. That's in fact the essential beauty of a computer, that it's able to do something today that no one even imagined possible 10 years ago. And if you would have turned that computer 10 years ago into a microwave, then why would the applications keep coming? And so we believe in the richness of innovation and the richness of invention, and we want to create an architecture that let inventors and innovators and software programmers and AI researchers swim in the soup and come up with some amazing ideas. Look at transformers. The fundamental characteristic of a transformer is this idea called attention mechanism. And it basically says the transformer is going to understand the meaning and the relevance of every single word with every other word. So if you had 10 words, it has to figure out the relationship across 10 of them. But if you have 100,000 words, or if your context is now as large as read a PDF and read a whole bunch of PDFs, and the context window is now like 1 million tokens, processing all of it across all of it is just impossible. And so the way you solve that problem is there are all kinds of new ideas, flash attention or hierarchical attention, or all the wave attention I just read about the other day. The number of different types of attention mechanisms that have been invented since the transformer is quite extraordinary. And so I think that that's going to continue, and we believe it's going to continue, and that computer science hasn't ended, and that AI research has not all given up, and we haven't given up anyhow, and that having a computer that enables the flexibility of research and innovation and new ideas is fundamentally the most important thing.
One of the things that I'm just so curious about, you design the chips. There are companies that assemble the chips. There are companies that design hardware to make it possible to work at nanometer scale. When you're designing tools like this, how do you think about design in the context of what's physically possible right now to make? What are the things that you're thinking about with sort of pushing that limit today?
The way we do it is even though we have things made, like for example, our chips are made by TSMC. Even though we have them made by TSMC, we assume that we need to have the deep expertise that TSMC has. And so we have people in our company who are incredibly good at semiconductor physics, so that we have an intuition for what are the limits of what today's semiconductor physics can do. And then we work very closely with them to discover the limits, because we're trying to push the limits. And so we'll discover the limits together. We do the same thing in system engineering and cooling systems. It turns out plumbing is really important to us because of liquid cooling, and maybe fans are really important to us because of air cooling. And we're trying to design these fans in a way almost like, they're aerodynamically sound, so that we could pass the highest volume of air, make the least amount of noise. So we have aerodynamics engineers in our company. And so even though we don't make them, we design them, and we have the deep expertise of knowing how to have them made. And from that, we try to push the limits.
One of the themes of this conversation is that you are a person who makes big bets on the future. And time again, you've been right about those bets. We've talked about GPUs, we've talked about CUDA, we've talked about bets you've made in AI.
Self-driving cars, and we're going to be right on robotics. And
this is my question.
Yeah,
what are the bets that you're making now?
Omniverse. The latest bet, of course, we just described at the CES, and I'm very, very proud of it, and I'm very excited about it, is the fusion of Omniverse and Cosmos, so that we have this new type of generative world generation system, this multiverse generation system. I think that's going to be profoundly important in the future of robotics and physical systems. Of course, the work that we're doing with humanoid robots, developing the tooling systems and the training systems and the human demonstration systems and all of this stuff that you've already mentioned, we're just seeing the beginnings of that work. And I think the next 5 years are going to be very interesting in the world of humanoid robotics. Of course, the work that we're doing in digital biology, so that we can understand the language of molecules and understand the language of cells, and just as we understand the language of physics and the physical world, we like to understand the language of the human body and understand the language of biology. And so if we can learn that and we can predict it, then all of a sudden our ability to have a digital twin of the human is plausible. And so I'm very excited about that work. I love the work that we're doing in climate science, and be able to, from weather predictions, understand and predict the high resolution regional climates, the weather patterns within a kilometer above your head, that we can somehow predict that with great accuracy. Its implications is really quite profound. And so the number of things that we're working on is really cool. You know, we're fortunate that we've created this instrument that is a time machine, and we need time machines in all of these areas that we just talked about, so that we can see the future. And if we could see the future and we can predict the future, then we have a better chance of making that future the best version of it. And that's the reason why scientists want to predict the future. That's the reason why we try to predict the future in everything that we try to design, so that we can optimize for the best version.
So if someone is watching this and maybe they came into this video knowing that NVIDIA is an incredibly important company, but not fully understanding why or how it might affect their life, and they're now hopefully better understanding a big shift that we've gone through over the last few decades in computing, this very exciting, very sort of strange moment that we're in right now where we're sort of on the precipice of so many different things. If they would like to be able to look into the future a little bit, how would you advise them to prepare or to think about this moment that they're in personally with respect to how these tools are actually going to affect them?
Well, there are several ways to reason about the future that we're creating. One way to reason about it is, suppose the work that you do continues to be important, but the effort by which you do it went from being a week long to almost instantaneous. That the effort of drudgery basically goes to zero. What is the implication of that? This is very similar to what would change if all of a sudden we had highways in this country. And that kind of happened, in the last industrial revolution. All of a sudden we have interstate highways. And when you have interstate highways, what happens? Well, suburbs start to be created, and all of a sudden, distribution of goods from east to west is no longer a concern. And all of a sudden gas stations start cropping up on highways, and fast food restaurants show up, and so on. Some motels show up because people traveling across the state, across the country, just wanted to stay somewhere for a few hours or overnight, and so all of a sudden new economies and new capabilities, new economies. What would happen if video conference made it possible for us to see each other without having to travel anymore? That all of a sudden it's actually okay to work further away from home and from work and live further away. And so you ask yourself kind of these questions. What would happen if I have a software programmer with me all the time, and whatever it is I can dream up, the software programmer could write for me. What would that do? What would happen if I just had a seed of an idea and I rough it out, and all of a sudden a prototype of a production was put in front of me, and how would that change my life, and how would that change my opportunity, and what does it free me to be able to do, and so on and so forth. And so I think that the next decade, intelligence, not for everything, but for some things, would basically become superhuman. And so I can tell you exactly what that feels like. I'm surrounded by superhuman people, super intelligence from my perspective, because they're the best in the world at what they do. And they do what they do way better than I can do it. And I'm surrounded by thousands of them. And yet, it never one day caused me to think all of a sudden I'm no longer necessary. It actually empowers me and gives me the confidence to go tackle more and more ambitious things. And so suppose now everybody is surrounded by these super AIs that are very good at specific things, or good at some of the things. What would that make you feel? Well, it's going to empower you. It's going to make you feel confident. And I'm pretty sure you probably use ChatGPT and AI, and I feel more empowered today, more confident to learn something today. The knowledge of almost any particular field, the barriers to that understanding it has been reduced. I have a personal tutor with me all of the time, and so I think that feeling should be universal. And if there's one thing that I would encourage everybody to do is to go get yourself an AI tutor right away. And that AI tutor could, of course, just teach you things, anything you like, help you program, help you write, help you analyze, help you think, help you reason. All of those things is going to really make you feel empowered. And I think that's going to be our future. We're going to become superhumans, not because we're going to become superhumans because we have super AIs.
Could you tell us a little bit about each of these objects?
This is a new GeForce graphics card. And yes. And this is the RTX 50 series. It is essentially a supercomputer that you put into your PC. And we use it for gaming. Of course, people today use it for design and creative arts, and it does amazing AI. And the real breakthrough here, and this is truly an amazing thing. GeForce enabled AI, and it enabled Jeff Hinton, Ilya Sutskever, and Alex Krizhevsky to be able to train AlexNet. We discovered AI, and we advanced AI. Then AI came back to GeForce to help computer graphics. And so here's the amazing thing. Out of 8 million pixels or so in a 4K display, we're processing only 500,000 of them. The rest of them, we use AI to predict. The AI guessed it. And yet the image is perfect. We inform it by the 500,000 pixels that we computed, and we ray traced every single one, and it's all beautiful, it's perfect. And then we tell the AI, if these are the 500,000 perfect pixels in the screen, what are the other 8 million? And it fills in the rest of the screen, and it's perfect.
And if you only have to do fewer pixels, are you able to invest more in doing that because you have fewer to do, so then the quality is better, so the extrapolation that the AI does is better?
Exactly, because whatever attention you have, whatever resources you have, you can place it into 500,000 pixels. Now, this is a perfect example of why AI is going to make us all superhuman. Because all of the other things that it can do, it'll do for us, allows us to take our time and energy and focus it on the really, really valuable things that we do. And so we'll take our own resource, which is, energy intensive, attention intensive, and we'll dedicate it to the few 100,000 pixels and use AI to super-res it, up-res it, to everything else. And so this graphics card is now powered mostly by AI. And the computer graphics technology inside is incredible as well. And then this next one, as I mentioned earlier, in 2016, I built the first one for AI researchers, and we delivered the first one to OpenAI. And Elon was there to receive it. And this version, I built a mini version. And the reason for that is because AI has now gone from AI researchers to every engineer, every student, every AI scientist. And AI is going to be everywhere. And so instead of these $250,000 versions, we're going to make these $3,000 versions, and schools can have them, students can have them, and you just set it next to your PC or a Mac, and all of a sudden you have your own AI supercomputer, and you develop and build AIs, build your own AI, build your own R2-D2.
What do you feel like is important for this audience to know that I haven't asked?
One of the most important things I would advise is, for example, if I were a student today, the first thing I would do is to learn AI. How do I learn to interact with ChatGPT? How do I learn to interact with Gemini Pro? And how do I learn to interact with Grok? And these learning how to interact with AI is not unlike being someone who is really good at asking questions. You're incredibly good at asking questions, and prompting AI is very, very similar. You can't just randomly ask a bunch of questions, and so asking AI to be an assistant to you requires some expertise and artistry in how to prompt it. And so if I were a student today, irrespective of whether it's for math or for science or chemistry or biology, or it doesn't matter what field of science I'm going to go into or what profession I am, I'm going to ask myself, how can I use AI to do my job better? If I want to be a lawyer, how can I use AI to be a better lawyer? If I want to be a better doctor, how can I use AI to be a better doctor? If I want to be a chemist, how do I use AI to be a better chemist? If I want to be a biologist, how do I use AI to be a better biologist? That question should be persistent across everybody. And just as my generation grew up as the first generation that has to ask ourselves, how can we use computers to do our jobs better?
Yeah.
The generation before us had no computers. My generation was the first generation that had to ask the question, how do I use computers to do my job better? Remember, I came into the industry before Windows 95. Right? 1984, there were no computers in offices. And after that, shortly after that, computers started to emerge. And so we had to ask ourselves, how do we use computers to do our jobs better? The next generation doesn't have to ask that question, but it has to ask the obviously next question, how can I use AI to do my job better? That is start and finish, I think, for everybody.
It's a really exciting and scary and therefore worthwhile question, I think, for everyone.
I think it's going to be incredibly fun. AI is obviously a word that people are just learning now, but it's just, it's made your computer so much more accessible. It is easier to prompt ChatGPT to ask it anything you like than to go do the research yourself. And so we've lowered the barrier of understanding. We've lowered the barrier of knowledge. We've lowered the barrier of intelligence. And everybody really ought to just go try it. The thing that's really, really crazy is if I put a computer in front of somebody and they've never used a computer, there is no chance they're going to learn that computer in a day. There's just no chance. Somebody really has to show it to you. And yet with ChatGPT, if you don't know how to use it, all you have to do is type in, I don't know how to use ChatGPT, tell me. And it would come back and give you some examples. And so that's the amazing thing. The amazing thing about intelligence is it'll help you along the way and make you superhuman, along the way.